Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, and this is my continuing feature on the Math Lovers book. And every week I feature a biography of a famous mathematician throughout history. I have 80 of them all together. They're at the end of the second volume, the volume in the middle shown here. And today I'm up to the sixth of 80 on my list, and that's Archimedes. And he lived from about 287 BC to 212 BC. Here's a picture of him, I guess what people believe he looked like. And he was amazing. I mean, he's got to be the greatest. I think he's the greatest ancient mathematician of all time. I mean, he just blows all the others away, in my opinion, in terms of what he was able to accomplish. Not only was he a mathematician, but he was also a physicist and an engineer. And physics didn't even really exist, at least not in the way we understand it today in ancient times. But I would still call him a physicist because he, he just. Anyway, I'm going to go over his major accomplishments today. I think the one that's most well known of his is Archimedes' principle. This is what he discovered in the bathtub. I mean, before I describe what it says, the principle is basically that it's a displacement. It's also called the displacement law. And so imagine you have a screw. That's what's shown on this picture. So you have a screw with a given mass or given weight. You put it in water, it'll displace the same volume of water. I mean, this is why it's useful, because if you want to measure the volume of this screw, all you have to do is put it in water, and the amount the water goes up is equal to the extra volume of the water in this container is equal to the volume of the screw. And the reason for that is because water is an incompressible fluid, and so its volume doesn't change. But Archimedes just he was given a problem. I think most people know this story. The king of I guess it was the king of where he was living. I think it was Syracuse. Thought that he had a gold crown, and he thought that people who made his crown it wasn't pure gold, but he couldn't prove it. And he wanted Archimedes to prove it. He wanted Archimedes to prove that his crown wasn't made of pure gold. So what Archimedes did was, I think he made a replica of the crown. I don't know how he was able to get the gold, but he knew that he knew the density of gold, I guess, or maybe he made a replica where he knew what the weight of the crown should have been. What he did, the problem was he had to figure out the volume of the crown because he knew the density of gold, but he couldn't figure out how to compute the volume of this crown because it's irregular shaped solid. I mean, it was shaped like a cube or a sphere. He could have calculated, but it was shaped like a crown, and so he was wondering how the hell is he going to measure the volume of the crown. But then he was taking a bath one day, and he when he went to the bath, when his body displaced the water in the bath, and then he realized he basically discovered this law of displacement. And he was like so excited, he realized he could use it to measure the volume of the crown. He got so excited, he ran out of the street naked, yelling, "Eureka! I found it!" And this is kind of a music story. But then he did figure out how to measure the volume of the king's crown, and he determined that it wasn't pure gold, and he got naturally rewarded for that by the king because the king was very happy to be that he discovered his crown wasn't pure gold. And so anyway, that was his first big accomplishment. And then another one was he discovered the principle of the lever. He discovered, we know how levers are balanced. The raw law is M1x1 equals M2x2, or here they call it A and B. So M1A equals M2B. And here you got a big mass on the left and a small mass on the right, but since the big mass is closer to the fulcrum, it has to be a larger mass to balance the smaller weight on the right. And this is a very useful principle, and it was so useful. If you make one end as long, you can make one end as long as you want, and the other as short as you want. So you can lift an arbitrarily heavy weight this way. Of course, it's not going to move very far. but you can still move it. And I guess Archimedes was so moved, part of the pun, by this principle. He had a famous quote. He said, "Give me a place to stand, and I will move the world." And so anyway, and then another thing, this was a very useful invention he made, was called Archimedes screw, and this was a screw for drilling water out of the ground. If you wanted it, this is very useful for irrigation. So imagine you had a big field or something, and you wanted there was water underground or there's water out of the sea. And how would you get the water from the sea to the land? Well, he built this device called an Archimedes screw. He literally screwed the water from the ocean or from the ground onto the field. That's how he's able to get water out. And I think this is still used in some form or other for irrigation. So that was a very useful invention. And then one of his best mathematical discoveries was he discovered what's called the method of exhaustion. And he used this method to come up with a very accurate estimate of pi. As a matter of fact, it was the most accurate estimate anybody had come up with for pi at the time. It's a very simple method. I mean, it's called the method of exhaustion. And the idea is you can approximate a circle, more technically a disk, as it's known in math. You can approximate a disk by a regular polygon. So in this diagram, there's five regular polygons shown. The one on the top left has 6 sides, and then the one below has 12. One below that has 24, and then the two on the right have 48 and 96 sides. And what Archimedes did, he actually discovered a very important law for computing. Basically, it was a trig function. He could compute the sine of theta over 2 in terms of the sine of theta. I think the equation, if I'm not mistaken, well, I better not say it because I don't want to get it wrong. But there is a formula that'll allow you to calculate. It's called a half angle formula, and you can apply the half angle formula to compute the area of a regular polygon with two n sides in terms of a regular polygon with n sides. Unfortunately, calculus wasn't invented yet. Archimedes never came up with a concept of a limit. If he had, I think he would have discovered calculus, because the idea in calculus is you just let the number of sides go in infinity. And then you can come up with a formula for pi in terms of a limit. But the Greeks never did that. Archimedes never did that, and the Greeks in general never did that. They never came up with a concept of infinity. Not even zero, either. I think you kind of need zero and infinity to get calculus, and the Greeks didn't do that, including Archimedes. But he was able to use, by using a 96-sided polygon, he came up with a very tight inequality for the value of pi. I think he came up with it had to be between 3 and 10^71 and 3 and 1/7, roughly between 3.1414 and 3.1429, if I'm not mistaken. So about 3 decimal places, roughly 3.142. And that was the most precise estimate of pi that was known at that time. Of course, now we know it's like 100 trillion digits, but this was the first. Actually, his method was used, as late as I think the 16th century. There were other mathematicians. There was a guy named von Soylon, I think around 1600, who actually used Archimedes' method. He used it for a polygon with I don't even know how many sides, something like some ridiculous number of sides. But he used it to come up with an estimate of pi that was accurate to 35 decimal places. Pretty amazing. Um, so that was the method of exhaustion. And one last thing he did, he came up with a principle of the parabolic mirror. And this, I believe, is a legend. This didn't really happen, but allegedly he used mirrors in the war against. I think it was a Peloponnesian War or something. It was a war in Syracuse, where supposedly the Greeks they used them in a war effort supposedly to burn enemy ships, by concentrating sun's rays using the principle of the parabolic mirror. I don't think this really happened, but according to legend, Archimedes did this, and they were able to burn ships at sea. I don't think they actually did this, but he did come up with a principle of the parabolic mirror by which you can focus sun rays onto a point and burn things. So anyway, those were just some of his accomplishments. They're really really amazing. Like I said, polymath, I guess you would call him, mathematician, physicist, and engineer. And I believe architecture. The word architecture comes from Archimedes and arch. So pretty amazing guy. Anyway, that concludes my profile on Archimedes. Thank you for watching. Long live math, and I'll see you guys next time. Bye.